Hello everyone. So I will start from where I left in my earlier class, which was the matter wave. Now, before going to that in details, first we need to think how can we combine the ideas of matters having both wave property and particle property, because these two are two very distinct things. As when you consider a particle, what do you mean by a particle? Some amount of matter confined in a space, or it has some particular position as well as it moves with some velocity. But what comes to your mind when you think of a wave? What comes? If you consider a sine wave, so it will be a wave which is spread through infinity, has some ups and downs. So how can you combine these two things? A wave has no particular position, whereas a matter or particle has a distinct position. So to combine these two, the concept of wave packet came into account. So what do you mean by a concept of wave packet? Wave packet is actually nothing but superposition of a very large number of waves having their wavelength in a particular range. For that, you first need to know about beats. I think you have already read about beats in sound waves in 10 plus 2. So we will do it here also in details. So for that I need to share the screen. Okay. So that before going to the web packet in details, first, okay. As I say, in a web packet, there is superposition of a very large number of waves. And how is wave packet formed? For that, you need to know about the bits, as I said. What happens in bits? In bits, two waves superpose with slightly different frequency. And when they superpose, what happens? Look at this picture. Here I have also tried to superpose two waves having slightly different frequencies. They form beats. That means the amplitude is not same for every crest. Some crests have very large amplitude, whereas some other crests, they have some lower amplitude. Now this is for superposition of two waves. Now what happens if you superpose more number of waves? You will see that the beats means the position of maximum amplitude for the whole waves. That means here is one beat, here is another beat. So what happens when you superpose more number of waves? The beats, they are separated by larger distance then, and the height of the peaks at the beats, they will be greater. So for two waves, we see that the beat look like something, look like this. And what happens if you put a very large, let us say ideally infinite number of waves having different frequencies together and superpose them? What happens? There will be practically one beat at a definite position, and this dot line, look here, this is actually called the wave packet. So it will look like a packet. So if you superpose a large number of waves together, a wave packet is formed. And let me check whether we have that picture or not. Okay. Okay. So we don't have the picture right now in this file. So let me pause here. Share. Okay, look at this picture. Here I have superposed this one, and the resultant looks something like this. So if you increase the number of waves, the resultant will look something like this. That means the peaks or the beats, they will be far from each other, and the intensity at the beats will be larger if you superpose a large number of waves. And if or when the number of waves is of the order infinite or very large, then what will we see? We see that all the disturbance of the waves is confined to a specific distance. So we get all the disturbance in this delta x region and nothing beyond that. And this position or around the mid position, it will be maximum. So very high will be the amplitude, but it will have a definite length which we denote by delta x. We will later find the uncertainty principle from here, but before that, this is how a wave packet looks like. Now we will go to group velocity and phase velocity. As you know, a wave packet is made up of large number of waves. Each waves can have individual velocities which will be termed as phase velocities, and the velocity of the wave packet itself, or the velocity by which this peak of the wave packet moves, it is known as the group velocity, or the velocity with which the whole group of waves or the peak of the wave packet moves is known as the group velocity. Now we are going to the notes. Okay, 1 minute. Okay. So first we come to phase velocity. Now about the property of the matter waves, we will discuss later in details in the second part of quantum mechanics, because as I said, both the wave property and particle property can be combined through wave packet only. A particle can stay anywhere inside the wave packet, and we will know the probability of finding the particle at a particular position by the amplitude square of the wave. Where the wave packet has less amplitude, the probability of finding the particle will be less. Where the wave packet has the maxima or the crest of the wave packet, at that position, the probability of finding the particle will be maximum. Thus, we come to a probabilistic domain from a deterministic domain of particles. What happens for particles, or just if suppose you are asked what is the position, you will tell some point xyz coordinates. But in this case, when we talk about wave packets, we cannot surely say that the particle is at that particular position. But what we say that it has 20% probability of finding the particle at that particular position. 60% probability there and 40% or 20% probability there, 0% probability there. So everything we talk will be in terms of percentage or probabilities. So from deterministic one, we come to a probabilistic one when we consider the wave packet. So a wave which was spread through infinity is now concentrated to a specific volume or specific area. So it is not throughout infinity. So we are concentrating the wave, and when we consider the particle aspect, the particle was at a point, it is now not at any particular point, but it can be inside a specific range. So that is how we combine the wave property and particle property both through the concept of wave packets. Now, to construct a wave packet, we need a number of waves. For that, we need to know what is phase velocity and group velocity. Phase velocity means the individual or the velocity of individual waves having a constant phase. So what will be the mathematical expression for that? Suppose y is equal to a sine omega t minus phi. This is the equation of any simple sine wave. So it can be written as y equals to a sine omega into t minus x by v. So you can get, you can easily do this calculation. It is already given here. So if the velocity of the wave is given by v, here we have written v, the velocity of the wave. So the phase of the wave is given by phi equals to omega into t minus x by v, which is the argument of sine. So for a constant phase, del phi del t has to be 0, because phase constant means it will, the first derivative will be obviously be 0. So for a point of constant phase, del phi del t is 0. From there we get that v equal to dx dt at constant phi. Now dx dt is nothing but the vp or phase velocity. So v is the velocity with which a wave having a constant phase moves forward, and it is called the phase velocity, which is the velocity of propagation of individual wave. The propagation constant k is given by omega by vp. So we can write vp equals to omega by k. So you get this equation from here, a sine omega t minus kx. So it is omega into x by vp. Now we come to group velocity. So while getting the formula of group velocity, we are using the simplest one, which is the superposition of two waves. So here we have superposed two waves with slightly different frequency, and the amplitude has kept same. So the first equation is y1 equals to a sine omega t minus kx, and the second one is y2 equals to a sine omega plus delta omega. This will be delta omega. Students, please make it correct. Omega plus delta omega t minus k plus delta kt. As the frequency is different, both omega and k will be different because they are dependent on the frequency as well as the wavelength. Now, according to the superposition principle, y will be given by y1 plus y2. So if you add both of them, you get this equation: 2 cos minus of delta omega by 2t plus delta k by 2 into x into sine of 2 omega plus delta omega by 2 into t minus 2k plus delta k by 2 into x. Now the assumptions. Here comes the main part. As delta omega and delta t are much less than omega and t, we will neglect them in the sign equations, and here we will use d instead of delta. Now the equation reduces to, if we neglect delta omega and delta k with respect to omega and k, we get y equals to 2a into cos of something into sine omega t minus kx again, which is equation of a wave. But the difference is here the amplitude. Amplitude contains a cos part. That means the amplitude will be varying with a cos function. That is why the beats came. So the amplitude depends on time and varies with time with circular frequency delta omega by 2, and it is given by capital A equals to 2a cos delta omega by 2t minus delta k by 2x. So for maximum amplitude, we get Vg equals to limit delta k tends to 0 delta omega by 2 divided by delta k by 2. What we did just in case of Vp. We get the velocity as, sorry, we get the velocity is equal to coefficient of this divided by coefficient of this, where this one, coefficient of x divided by coefficient of t. Similarly, here also the velocity will be given by coefficient of x is given by delta k and coefficient of t is given by delta omega. Sorry, it will be the inverse. So it will be coefficient of t divided by coefficient of x. So delta omega by delta k, if we take delta omega and delta k too small, it will be d omega dk. So Vp is given by omega by k and Vg, the group velocity, is given by d omega dk. Now, we know omega equals to k Vp because Vp is omega by k. So Vg will be d omega dk. This one will also be k. There are too many mistakes here. You have to correct it. D omega dk. So d dk of k into Vp. So it will be Vp plus k into dVp dk. Now, Vp is also a function of lambda. You can just write Vg equals to Vp plus k into Vp k into dVp d lambda into d lambda dk. So what is the relation of lambda and k? K is given by 2 pi by lambda. So dk is given by minus 2 pi by lambda square d lambda, or d lambda dk is given by minus lambda square by 2 pi. So Vg is equal to Vp minus k into lambda square by 2 pi dVp d lambda, or Vg equals to Vp minus lambda into dVp d lambda. This relation is also very important. So this derivation may also come in the exams. Now one correction, please note that it is a correction. Vp will be greater than Vg. This is wrong. Vg is greater than Vp is written. So Vp, as you see from here, Vg will always be less than Vp. So group velocity will always be less than the phase velocity of individual waves. For some cases where the medium is non-dispersive, Vp does not depend on lambda. For that, dVp d lambda becomes 0 and Vg is equal to Vp. So Vg is equal to Vp for non-dispersive medium where all the wavelengths move with same velocity. So it is valid for electromagnetic waves in vacuum and elastic waves in homogeneous medium. Now, one relation we get from here, there is another relation of Vg and Vp. We are going to derive that. So our Vp is given by omega by k. Now, energy is given by h nu for any photon particles, or omega is written by E by h cut. Similarly, k is written by P by h cut. So you can replace omega by k as E by P. So from here we get Vp equals to E by P. Similarly, we get Vg equals to d omega dk. So it will be dE by dP. Now for a relativistic particle, the energy equation is written as E square equals to P square C square plus M0 square C to the power 4. Remember, we got these equations for photon particles. Now we are going to apply it for relativistic particles. It is for matter. So Vg is given by dE dP. So for relativistic particle, the energy equation is given by this. Now if you do the first order derivative, it will be 2E into dE equals to 2P into dP into C square, plus the second term will be 0 because m0 c square both are constant. So dE dP is given by PC square by E. Now P is given by mv and E is given by mc square. So both of them cancel out and we get dE dP equals to v, where v is the velocity of the particle. So we get de Broglie wavelength for a relativistic particle is given by particle velocity. Similarly, for a non-relativistic particle, E is given by P square by 2m, the kinetic energy, where P equals to mv. So dE dP is given by P by m. Okay. And P by m is nothing but v. So in both cases, group velocity represents the particle velocity. Now can you find out the connection? Wave packet was formed by a large number of waves having slightly different frequencies in a certain frequency range, and the group velocity was the velocity of the peak of the wave packet. Now from mathematics we see that it is also equal to, the group velocity is also equal to the velocity of the particle. So that means particle is particle is inside the wave packet and the wave packet is moving with the velocity of the particle. So it is a highly interesting thing. Now the relation between Vp and Vg, once again, Vp is E by P, is E equals to mc square and P equals to m into V of particle. In both the cases, V of particle is Vg, the group velocity. So cancels out, we get Vp equal to C square by Vg, or Vp into Vg equals to C square. So the product of group velocity and phase velocity is equal to C square, where C is the velocity of the light. Now we are going to discuss the Heisenberg's uncertainty principle, which comes from the concept of matter waves. Now once again I am going to the picture of, okay, stop share. Once again I am going to the picture of the wave packet. So look at this picture. As I said, a wave packet is formed by superposition of a large number of waves having their wavelength slightly different but inside a certain wavelength range. Okay. Now, when the wave packet is formed, you can easily see that the position of the particle is not certain. So as I said, the position or the probability of finding out the position of the particle is dependent on the amplitude square. So it is greater where the amplitude has the highest, it is greatest. Where the amplitude is 0, look at this area. Here the amplitude of the wave is 0. So here the particle has no probability of finding out. So we can say that the particle is confined within this delta x region. So we cannot measure the position of the particle with 100% accuracy. it has some amount of uncertainty which is denoted by this delta x. So this is the uncertainty in position. What is the uncertainty in momentum? As I said, when you construct a wave packet, you superimpose waves having their wavelength in a particular frequency range. That means there will be some amount of delta nu or some range of delta nu inside which the waves can be. So if there is a range in delta nu, that means there is a range in lambda also. So there will be some delta lambda values also. And lambda corresponds to momentum because lambda is given by h by p, or p equals to h by lambda. So simply, if we have a delta lambda, we will have a delta p. So there will be uncertainty in the momentum also. Heisenberg's uncertainty principle states that you cannot accurately determine both the position and momentum of a particle at the same instant of time. The more accurate the position, the less accurate the momentum, or the more accurate the momentum, the less accurate the position. It will be clear from this picture, because if you increase the number of superposing waves, that means you are increasing the delta lambda value as well as you are increasing delta p, and as a result the area where we get some amount of the wave, that means the length of the wave packet, it decreases and the height increases. Height corresponds to, that height gives you the probability. That means its position is being more and more accurate if you increase the number of superposing waves, but its momentum gets less accurate. And if you decrease the number of superposing waves, what will happen? The wave packet will flatten. That means the probable delta x value, the delta x value increases, but the delta p value decreases. So if one increases, the other one must decrease, and they have some relation, and the relation is given by the Heisenberg's uncertainty principle, which is delta x into delta p is greater than equal to h cut, delta x into delta px. So the product must be greater than equal to h cut, where h cut is h by 2 pi, where h is the Planck's constant. So x and p are called conjugate variables. Similarly, E and T, energy and time, they are also conjugate variables. So for them also we get delta E d into delta T greater than equals to h cut. So, and for a more accurate calculations, we get actually delta x into delta px greater than equals to h cut by 2, or delta E into delta T greater than equal to h cut by 2. So for more accurate calculations, this equation is used. Now, using these Heisenberg's uncertainty principles, various phenomena, they were also confirmed. So we will discuss about them in details. For example, electrons cannot reside inside a nucleus and so on. So we will discuss about them in details when we will have a discussion on the problems. So we will have a discussion on the problems from quantum mechanics. There I will discuss about those problems in details. For then you do those problems on your own. If you have any difficulty, please ask in the Google Classroom, because no one is directly responding there. Some people are telling me through SMS that this portion I cannot understand. It will be difficult for me to get so much of them. So it will be easier if you write all your problems in the Google Classroom. If you have any doubt or question, please ask there. I will try my best to solve them. So till then, goodbye. Okay.